Thevenin and Norton theorem for the circuit containing only independent source. So the step for the Norton and Thevenin for a circuit that contain only independent source. Okay, so the first step is we remove the load terminal and sketch the circuit. And then the next step is we determine the RTH or RN or R equivalent. And then we determine the VTH or V open circuit and IN or I short circuit. And then we sketch the Thevenin and Norton equivalent circuit. Okay, so for this, in order to determine the R equivalent, if we have a voltage source, so we need to do a short circuit. If we have a current source, we need to do an open circuit. And then we can find the resistance that's seen from the load terminal. Okay, for the Thevenin open circuit voltage, VTH or VOC, V open circuit, we determine the voltage that appear at the load terminal. For Norton short circuit, IN or I short circuit, the short circuit in the terminal AB, so we need to find the short circuit current I as short SC, which is a short circuit. Okay, so note that the RTH is equivalent to the RN or R equivalent. So in order to find this R equivalent, we can use this formula where R equivalent is equal to V open circuit divided by I short circuit. This is example 4.3. By using a Thevenin's and Norton theorem, sketch the equivalent circuit to left of the terminal in a circuit shown below. Then find I. So this is the load. So the first step is we remove this load and then we find for the RTH. In order to find the RTH or R equivalent, so we need to open circuit the current source and then short circuit the voltage source. So we will get this equivalent circuit. And then to find the RTH is by looking at this terminal A and B. So from this figure, the RTH is actually equal to the 4 ohms parallel with 6 plus 6, which is this we will get 1 over 4 plus 1 over 12. Inverse 1, you will get this is equivalent to 3 ohm. Okay, and then for this two circuit, so this circuit B here is to find the VTH or V open circuit. So at this load, we make it open circuit and then we find the VTH at this two terminal A and B. Okay, so here from this one, we want to show you the circuit source transformation. Okay, so from the voltage series with this resistor, so we can change to the current source parallel with the resistor by using the VTH is equal to the R IN times by R, or if you want to find the IN is equivalent to the VTH divided by RN. Okay, so here is we want to find the V open circuit, and for this figure C is we want to find the I Norton, where at this load A and B, we just make it a short circuit in order to find the IN. In order to find the Norton and Thevenin equivalent circuit, the first step is you need to remove your load terminal. Okay, so this is your load, so you need to remove this load terminal. Okay, and then we sketch for the new circuit where you just leave your terminal A and your terminal B open. Okay, and then the second step, you need to find the R Thevenin or R Norton, or also we can call it R equivalent. So if in order to find this R equivalent, if you have a voltage source, you need to do a short circuit. If you have a current source, you need to do an open circuit. Okay, so I can redraw this circuit, the new circuit. And your RTH, your R equivalent should be seen at this terminal A and B. So from here, we can see that your RTH is equal to 4 ohm parallel with this 6 and 6 in series. Okay, so you simplify this, you will get your RTH is equal to 3 ohm. And then for the third step, we want to find the VTH. So in order to find the VTH in this circuit in step 1, okay, so we need to find the VTH at this open circuit terminal A and B. Okay, so this is your terminal A, this is your terminal B. So this is the place where we want to find the VTH. So this is your 4 ohm, and then this is your 6 ohm. This is your 6 ohm, 2 ampere plus minus 12 volt. Okay, so to find this, we can use a Kirchhoff current law at node V node. So let's say this is a node V node, so I want to find this V node first. Okay, by using a Kirchhoff current law at node V node, so my V node minus 12 divided by 6 minus 2 plus V node divided by 6 plus 4 equal to 0. So if we simplify this, you will get your V node is equal to 15. Okay, so now at this V node is equal to 15. So but what we want to find is the VTH. So from here we can use a voltage division. Okay, so in order to find the VTH is equal to 4 divided by 6 plus 4 times by 15, you will get your VTH is equal to 6 volt. And the next step, we want to find the IN. Okay, so from the first circuit in step 1, okay, so at this terminal A and B, we need to do a short circuit. So you need to find your IN at this short circuit where this is your 6 ampere, 4 ampere. So here, if you can see your IN here at this terminal A and B is parallel with this 4 resistor. So the 4 resistor will short circuit by this terminal A and B. Okay, so now your equivalent circuit will be this is your terminal A, this is your terminal B, this is IN that we want to find. This is a 6 ohm, 2 ampere plus minus 12 volt. So here we also can use a KCL at this node V1. So KCL at node V1, we will get V1 minus 12 divided by 6 minus 2 plus V1 divided by 6 is equal to 0. So your V1 is 1 over 6 plus 1 over 6 equal to 12 divided by 6 plus 2. So you will get your V1 divided by 3 is equal to 4 and your V1 is equal to 12 volt. So at this point your V1 is equal to 12 volt. So in order to find IN, so your IN is at this point, so IN is equal to V1 divided by 6, which is 12 volt divided by 6 ohm. You will get your IN is equal to 2 ampere. Okay, so now we have your RTH, you have your IN, and you have your VN. So for the fourth step is we want to sketch the Thevenin and Norton equivalent circuit. So this is the Thevenin equivalent circuit. So this is your RTH. This is your VTH, where your RTH is equal to 3 ohm. This is terminal A. This is your terminal B. And then this is your VTH equal to 6 volt. And then if you want to put back your load here, okay, so this will be your load, which is equal to 1 ohm. Okay, for the Norton circuit is the current source, the current IN is parallel with the RTH. So your RTH is here equal to 3 ohm, and then this is your current IN is equal to 2 ampere. So this is actually equivalent to RN. And then this is your terminal A, this is your terminal B, and then this is your load, which is 1 ohm.